The first example is the verification example against the ISO standard thermal bridges in building construction. This example represents the concrete slab laid on the steel frame, and the frame and the slab are in contact through the insulating plate. So this is some kind of the roof element. The bottom surface is in contact with the warm air inside the building, and the air temperature is 20 degrees Celsius. And the top surface is in contact with the cold air with the temperature of 0 degrees Celsius. And the surface thermal resistance is specified. Now, as this is not the solid to solid contact, but this is the solid to the gas contact, there is specific thermal conducting resistance. So this is the value of the thermal conducting resistance. The dimensions specified here are in millimeters. It is the static heat transfer problem, and the thermal conductivity of the concrete, of the insulation, of the air, and of the steel are specified. Our task is to calculate the temperature distribution and compare the temperature value in reference points. The reference points specified in the ISO standard are all the corners. So here, here, in this corner, in this corner. The geometry model features vertical symmetry, so only the right half is simulated. And on the axis of the symmetry, we will set the zero heat flux boundary condition. Now I will start QuickField. I will create the new problem. This is the problem name, and this is the location folder. As I said, this is the steady-state heat transfer problem. Now here you should draw the geometry model, or you can input the geometry model from the CAD drawing. I already have the CAD drawing prepared. Here it is. Now this is the geometry model. Here I should assign labels to every geometric object. Now what I have here. This is the concrete. This is the metal. This is the insulation. And this is the air. The bottom surface is warm air, and the top surface is the cold air. And this is the axis, the vertical axis. Now I have the geometry model labeled. So for each object there is the label here in the tree. And next step is to assign physical properties for each label. Now let's check. For the concrete I should specify 1.15, and for the insulation 0.12. Concrete 1.50. This is the static problem, so I do not specify the specific heat, nor I do not specify the mass density. And for the insulation 0.12. For the air I specify 0.029, and for the metal specified 230. Next I should assign boundary condition. So as I said, at the vertical axis I have 0 heat flux. The warm air. This surface is in contact with the air, so I should specify the convection coefficient. The temperature is 20 degrees and the convection coefficient is reciprocal to this value. So I type this value. Now for the cold air, again I specify the convection. The temperature is 0 degrees Celsius and the convection coefficient is reciprocal to this value. Now everything is ready. I can build the mesh, save all problem files and run the simulation. And here you can see the temperature distribution. You can adjust the field picture. I will switch off the color map and switch on the isotherms plot. To calculate the heat flux, you should build the integration contour. You should use the contour tool and select the top or the bottom edge. Here you can see the contour is built, and then you follow to the integral calculator and calculate the flux. And to calculate the local values, you should use the local value calculator. So this is the temperature at this point. I can manually adjust the point coordinates. Now this is the temperature. And this is the overall heat flux. Now let's compare these values with the reference values. Here you can see that the heat flux should be 9.5. If we compare the difference, in QuickField I have 9.5. 116 divided by 9.5 is, it is 1/10 of the percent. The difference in the flux value is only 1/10 of the percent. Now let's compare the temperature value. In QuickField I have 16.335 and in reference I have, now this is the reference and this is the point J. There is no reference temperature for the J point, so let's choose another point, for example D. I will click here and adjust the coordinates. No, it should be, yes, 6.2028. In a reference I have 6.3. Now let's compare the temperature and other reference points. For example, A, C, F. Let's zoom in and try again. Seven 7.07, 7.1. That's the point C. 7.90, 7.9. Now let's check the point F. It should be 16.4, and in QuickField I have 16.4. In order to pass the test, the difference between the measured value and of the temperature and the reference value of the temperature should be less than 0.1 Kelvin. And the difference between the measured heat flux and the reference heat flux value should be less than 2%. So you can see that QuickField passes this test.